Good afternoon. It is a great honor for me to be here to give my proposal presentation. My research focuses on improving geovisualizations to motivate consideration of climate change adaptation strategies by agriculture producers. Agriculture is directly and indirectly impacted by the changing climate. In the coming years, the world's agriculture producers will face the challenging task of increasing food production to keep up with growing population and growing consumption, all while take into consideration the impacts of climate change on production. Climate change is a geographic problem because when visualize the changing climate, it requires a geographic solution to understand global change patterns and the impacts at local communities. Climate scientists researchers developed the concept of climate visualization, which provides interactive research platforms that use computers to generate images that display the changing climate, as well as related mitigation and adaptation possibilities. There, there are there are a need for data visualization tools to interpret climate results that can be used by different stakeholders. Though climate tools are increasing, a recent annual Gallup environmental survey from March 2015 indicates that relative to other environmental threats or environmental issues, worries climate change is far down at the bottom of the list. In 2008, using nationally representative survey data on global warming beliefs, behaviors, and policy preferences in the United States, Lazarowitz and others identify 6 distinct groups of Americas. Global warming's 6 Americas. Since then, they have trackled the size of these 6 audiences and the ongoing evolution of their beliefs, behaviors, and policy preferences through a series of national surveys. They found out that the highest belief in global warming, this portion of the population are most concerned and motivated. On the other hand, that people who do not believe in climate change, their attitudes is dismissive, they are less concerned and less motivated. There is a growing body of the literature on agriculture producers' perception of climate change. As the survey results from Regisus 2013 indicated that producers do not believe that climate change will impact their crop production. Heaps and others categorized the focus group participants into which of the 6 Americas categories they could classify themselves with regard to climate. The majority responded cautious. It means that Kansas producers are aware that climate is changing. However, there are barriers for them to take action. There are communication gaps between the scientists and the public because the barriers preventing producers from engaging in changing their climate change adaptation behavior. The first barriers in the literature mentioned is lack of knowledge, known as the knowledge deficit model. A study by Yale University evaluated public knowledge about climate change. They assessed the results by letter graders A, B, C, D, and F, like a high school assignment. The straight scale results illustrate the problem. You can see that the majority of the population lack of the basic knowledge about causes, impacts, solutions, and the science about climate change. A second barrier is the psychological distance, the distance of climate change to explain the reason why the public think climate change is an abstract issue. As the Gallup survey shows again, the majority of the population, almost 2/3, believe that it is a future threat, that they do not believe climate change will actually pose a serious threat in their lifetime, compared to that 40% do. So we can say that portion of the public accept the fact that climate change is happening. They do not really think it is threatened to them now or even in their present lifetime, which reduces the immediacy of the threat in terms of motivations to deal with the issue. Some of the stakeholders are cognitive misers with limited climate information for decision-making characterized by relying on mental shortcuts. Most people lack of motivation and an ability to systematically and deliberatively process large amounts of information about a complex issue or topic. Instead, they employ a range of heuristic mental shortcuts to make decisions about complex issues. To improve agriculture producers' engagement, the scientific communities attempt to provide agriculture producers with more climate information. Contemporary climate data use research pointed out agriculture producers' needs. They want unbiased, trustworthy, and non-political resources. They want deliberative formats that are personal and local relevance in a way they can comprehend. They want accurate agroclimate information. They want the data easy to access. However, climate visualization tools are difficult to develop because of the heterogeneous, the agricultural producers, the heterogeneous climate data, and the multidisciplinary nature of the general or scientific purpose of using the climate data in terms of salience, credibility, and legitimacy. Scientists use visual elements to convey ambiguous information that words cannot. Visualization tools such as digital globes provide one way to bring together multi-scale spatial-temporal data sets. With the increasing technologies, agriculture producers use visual products to manage their farm operation. Bridging the communication gap needs more effort on knowing producers' climate information needs, developing climate visualization and communication expertise, exploiting the chances arising from sophisticated visualization and communication approaches, and smoothly supporting and integrating the alternative visualization and communication techniques into the user's ongoing research process. However, how to visualize climate information to communicate climate change to agriculture producers so that they will be motivated to consider climate change adaptation strategies, thus fill the communication gap. I proposed 3 objectives to answer the research question. This project will provide a novel approach for interdisciplinary research efforts to investigate the understudied topic of social climate literacy communication and climate spatial visualization science, 3 major themes based on Trumbull's 1999 visual learning dimensions. The conceptual framework guiding the study is shown in this figure and illustrates the goal of effectively communicating climate information by enhancing the ability of agriculture producers to think critically about and develop effective strategies and tactics regarding climate information. There are 2 different levels of involvement, high and low. As the elaboration likelihood model, ELM, suggests, high involvement groups are alarmed about climate change, while the low involvement groups are susceptible to dismissive information. For the low involvement group, their changes or shifts in attitude are related and require only peripheral heuristic cues. Peripheral information processing includes photos, visual maps, and attractive or highly credible sources. This given information should follow Trumbull's 1999 visual learning dimensions, knowledge, application, and evaluation to engage with low involvement groups, aiming to shift their attitudes towards climate change. This form the objectives of the study, which are set in this framework. Kansas is an important agricultural state, ranking 6th among the states for total agriculture production. Kansas has varied agriculture. Its largest crop is wheat and corn, and another valuable Kansas crop, soybean, followed by sorghum, grain, and hay. For livestock, the highest agricultural revenue in Kansas is generated by raising cattle and calves, followed by hogs and dairy products. Some revenue is generated by chicken eggs, sheep, and lambs. In terms of climate, Kansas has great gradients in temperature and precipitation. The spatial difference within the states varied, so it is a typical area to understand the climate change impacts. Because global climate change is likely to touch the lives of all Kansas during this century, and it is important to keep or increase the food production in the coming decades to meet the needs of food consumption. Objective 1,